What is Nvidia smoking? Nvidia's relentless innovation from AI supremacy to metaverse. Bets and eye-watering GPU prices feels like they're inhaling pure ambition. Even while some are shocked by the boldness, these high-stakes actions are not arbitrary, rather. They are deliberate bets to control the future of computers. In this video, we will go through the 7 bold decisions that define their high-risk, high-reward strategy, along with the reasons why critics cannot help but stare. Number 7. AI supremacy. Nvidia's rise to become the clear leader in AI hardware is one of the most important strategic turns in the history of technology. Although GPUs were initially created for video game graphics rendering, Nvidia's engineers realized in the early 2010s that artificial intelligence could be revolutionized by the same parallel processing architecture. By first optimizing its CUDA platform for machine learning frameworks, then adding specialized tensor cores to its Volta architecture, and finally developing whole system-on-chip designs, such as the Grace Hopper superchip, especially for AI workloads, the company made a series of thoughtful wagers. Nowadays, it would be nearly impossible to train state-of-the-art huge language models like GPT-4 or Gemini without Nvidia's H100 accelerators, which can execute matrix multiplications, crucial neural network operation orders of magnitude faster than traditional CPUs. Innovations like Transformer Engine, which optimizes attention processes, NVLink, which facilitates GPU to GPU communication, and whole reference architectures like DGX SuperPod, which act as models for AI supercomputers, have further solidified the company's position. Nvidia is actively defining what is feasible in the field of artificial intelligence with every new hardware generation, rather than merely keeping up with advancements in the field. Number 6. CUDA ecosystem. The software empire that Nvidia has created around CUDA is what really makes their strategy brilliant, not just hardware. The Compute Unified Device Architecture was first created in 2006 to provide developers with direct access to GPU parallel computing. It has now developed into a whole computer paradigm that has changed a number of sectors. The supremacy of CUDA is a result of multiple strategic advantages. First, it has a large installed base thanks to its early mover advantage. Currently, over 4 million developers have received CUDA training. Second, with specialized libraries like QBLAS for linear algebra, QDNN for deep learning, and RAPIDS for data science, Nvidia has consistently increased CUDA's capabilities. Third, the business makes sure that decades-old CUDA code continues to function on modern hardware by maintaining obsessive backward compatibility. The entire AI research community has standardized on CUDA-optimized tools, making it nearly impossible for competitors to enter the market, even with better hardware from AMD or Intel. By collaborating with all of the primary AI framework developers to guarantee that CUDA stays the default backend and launching programs like the CUDA Toolkit, which offers continuously updated GPU-accelerated libraries, Nvidia further solidifies this lock-in. Number 5. Omniverse and digital twins. The Omniverse is arguably Nvidia's most ambitious endeavor to develop a whole new paradigm for computing. Omniverse is essentially a real-time simulation engine for the real world, not just a 3D rendering platform. The foundation of it is Universal Scene Description, a framework created by Pixar that Nvidia has expanded into a full language for modeling and describing reality. The platform's revolutionary potential is demonstrated by industrial applications. Before making any physical alterations, engineers can optimize manufacturing lines by using Omniverse to build digital twins of whole factories. It is used by Lockheed Martin to simulate satellite constellations. It is used to model climatic systems by weather researchers. The way that Omniverse integrates Nvidia's whole technology stack, RTX ray tracing for photorealistic rendering, AI for physics simulation, and GPU acceleration for real-time multi-team collaboration, makes it exceptionally potent. While Nvidia's own AI tools, such as Magic 3D, can create 3D assets from text prompts, the platform's open extensibility allows it to link to industry-standard tools like Autodesk Maya or MATLAB. Nvidia is essentially positioned by Omniverse as the supplier of the digital infrastructure that will support everything from the metaverse to industrial automation. Number 4. Data center transformation. In the era of artificial intelligence, Nvidia's data center business completely reimagines what computing infrastructure implies. The company is developing completely new architectures for hyperscale computing, which is a significantly more ambitious strategy than just selling GPUs. By paying $6.9 billion to acquire Mellanox in 2019, Nvidia has access to vital networking technology that enables hundreds of GPUs to cooperate, with InfiniBand solutions providing latency as low as 1 microsecond. Data processing units from Nvidia, such as the Bluefield series, free up CPUs to handle whole data center functions including networking, storage, and security, resulting in what the firm refers to as zero-trust data centers. With its HGX platform, Nvidia has arguably made the biggest leap into comprehensive system design. These reference designs serve as models for AI infrastructure from cloud providers such as AWS and Microsoft Azure. Nvidia's latest innovation, the DGX Cloud, marks a significant change from the company's previous strategy of selling hardware to cloud providers to now providing AI supercomputing as a service to businesses directly. From chips to full-stack cloud solutions, this vertical integration offers Nvidia unparalleled control over the AI infrastructure stacks and generates a number of recurring revenue streams. Number 3. Autonomous machines. Nvidia systematically discovers and dominates upcoming computer frontiers as evidenced by its robotics and automotive strategies. Nvidia has progressed from selling simple chips to whole software-defined systems for autonomous cars. Multiple Orin SoCs with 254 TOPS each are combined with a full software stack that includes modeling tools, mapping solutions, and perception algorithms in the Drive Hyperion architecture. While robo-taxi startups like Cruise rely on it for fully autonomous operations, automakers like Mercedes employ it to allow Level 3 autonomy. At the same time, Nvidia's Jetson platform enables AI in edge devices. The Jetson AGX Orin, which has 275 TOPS in a credit card-sized module, makes it possible for everything from medical equipment to warehouse robots. Nvidia's robotics strategy is especially smart by giving Isaac Sim a robotic simulation platform that runs on Omniverse. The company makes sure that developers train and test their AI models in virtual environments prior to deployment, which naturally generates demand for Nvidia hardware throughout the entire development process. Nvidia is almost as essential to robotics as it is to AI data centers because of its full-stack strategy, which covers silicon, algorithms, simulation, and deployment. Number 2. Strategic alliances. Nvidia's collaboration approach demonstrates a deep comprehension of ecosystem dynamics. The company has positioned itself as an enabler for almost all of the major tech players rather than attempting to control every layer of the AI stack. Nvidia has symbiotic partnerships with all three hyperscalers in cloud computing. Google Cloud offers TPU alternatives while still mainly relying on Nvidia GPUs. Microsoft Azure incorporates Nvidia AI with its cloud services, and AWS offers EC2 instances with up to 16,000 H100 GPUs. With initiatives like the Nvidia Inception Accelerator, which offers over 15,000 AI entrepreneurs cheap gear and technical support, the business has similarly integrated itself into the AI startup ecosystem. When cloud providers create their own AI chips, such as AWS Trainium or Google TPUs, Nvidia responds by making its GPUs compatible with these solutions using technologies like NVLink. This shows that Nvidia can succeed even in competitive situations. By means of GPU grant programs, Nvidia has maybe most purposefully developed strong ties with academic researchers, guaranteeing that every new generation of computer scientists receives training on Nvidia hardware. This network of partnerships establishes a feedback loop in which the advancement of the whole IT sector is linked to Nvidia's plan. Number 1. Market adaptation. Nvidia has almost clairvoyant skills in handling market upheavals. The business has a history of quickly changing its strategy to transform possible disasters into opportunities. In response to the GPU boom-bust cycle caused by cryptocurrency mining, Nvidia developed specialized CMP mining chips while preserving supply for AI researchers and gamers. Nvidia developed processors like the A800 and H800 that were export-compliant within months of new rules during the tech tensions between the United States and China. Since remote work drove cloud usage and AI development, Nvidia was able to capitalize on the COVID-19 pandemic, which decimated many IT organizations. In conclusion, Nvidia isn't smoking anything, they're too busy printing money and rewriting the rules of computing. As rivals follow the fads of the past, Jensen Huang's team is already creating the reality of tomorrow. If you liked our video, please hit the like button and subscribe to our YouTube channel.